morning Year 3. I hope you've had a lovely week so far and you've had a really great chance to get a look at some of the maths that we've been doing and the different shapes and lines that we've been talking about. So today we're going to move on to 3D shapes. Now I know you'll have done some parts of 3D shapes in early years, so we're going to be really deepening our understanding of these today. Okay, so to start us off today, we're going to have a look at Flashback Thought, and we're going to be looking at some questions here. So I'd first of all like you to tell me the time on the clock. So on the analog clock, what time is it? Now again, if you want to challenge yourself, you could write this as a digital time. Tell me what the time would be digital as well. Then number 1, you're writing 3/10 as a decimal. So remembering how we turn 10, if it's tenths, where is it going to be on our HTO or further down the line? So how are we going to write this decimal? Then which fraction is equal to 1 whole? I want you to tell me which one is and why it is, but I also want you to tell me why the other ones are not as well, if you can, as an extra challenge. Number 3, how many centimetres are equal to 8 metres? So thinking about how many centimetres are 1 metre, so how many centimetres are going to be in 8 metres? And then for number 4, divide 48 by 2. So think about what method you could use for that as well. Have a go. Once you've had a go at that, come back and we'll have a look to see if you've got the answers correct. So let's have a look at our analog clocks. So first thing we need to do when we're looking at an analog clock is we need to look at the minute hand. So remembering that the minute hand is the longest hand, and we can see that the minute hand is at 3. However, remember that is not 3 minutes past, because there are 5 minutes between each number. So if I start from the 12 and I count round 12, 1, 2, 3, and if I count it up in my 5s now, 5, 10, 15, I know that it is 15 minutes past. I'm just going to write that down. Now, what is another way that we can say 15 minutes past? Because we wouldn't say it is 15 minutes past. You should have said that it is quarter past. Quarter past. Because remember, if I have got the face of a clock, at the top I have o'clock. If my minute hand gets to the bottom here, it will be half past. Because it's like you have chopped your pizza or your cake in half, and then if I cut it in half again into quarters, here would be quarter. Oh, just can't quite fit it on. Quarter past, and the other side would be quarter to the hour. So remember, it will be quarter past. Now I know then it is quarter past because my minute hand's on the 3, which is the same as 15 minutes past. Now I need to see which hour my hour has passed. Now obviously, because it has only gone 15 minutes past, it's not gone too many, so my hour hand hasn't moved too far past the number. So I can see that it is quarter past 8 because my hour hand is just slightly after my 8. Now for those people to get a bonus point, if you had turned this into a digital clock, remembering that first of all I need to put my colon and I need 2 numbers after which are my minutes, and depending on whether it is in 12 or 24 hours, you either put 1 number or 2 numbers before here. So I can have a look and I can see that if I look at which hour it has passed, so it has passed the 8, so I know my hour is going to be 8. And I know if I look how many minutes past, it has gone 15 minutes past. So it's quarter past 8 is the same as 8:15. So well done if you got that. You get a bonus point for that. So let's have a look at number 1. So number 1 is where we are turning 3/10 into a decimal. Now, if we write our HTO, remember then it becomes a decimal. And then after the decimal, we have tenths, and then we have hundredths. So if you wrote out your hundredths, tens, and ones column and showed this, then we can see if it was 3/10, not 3/10, because if it was 3/10, it would be 30, so it would go in my tens column. But because it is 3/10, I would put my 3 in my tenths column, put my decimal point in, and remember we can't just leave it as 0.3, we have to put my 0 before to make it 0.3. Just a quick practice on that then. Can you set yours up like this if you haven't done already? Now if I said I wanted to show 7/10, how would I write 7/10? Have a go, pause the video and then play it to see if we get it correct. So you should have said that 7/10, my 7 is going to go in my 10ths column, so I'm looking at my 10ths column. My 7 goes in my 10ths column because that is what the numerator is. I need to put in my decimal point, and if there's a missing column, we always need to put a 0, so you should have got 0.7. We're going to do one more. This time, I want you to write 9/10 as a decimal. Pause the video, off you go, and then play the video once you've done that. Okay, so again, I'm looking at my 10ths column, so I can look in my 10ths column up here. I know that my numerator is 9, so I'm going to put 9 in my 10ths column, put in my decimal point, and I have got a missing column, so I need to put a 0, so 9/10 is equivalent to 0.9 as a decimal. Okay, so number 2. You need to say which fractions are equal to 1 whole. So you could have drawn these out. Okay, so I've drawn out mine as a bar model. So I have got 3/5, so I know my denominator is the number of parts, so I've got 1, 2, 3, 4, 5. If I shade now 3/5, so I've got 1, 2, 3. Is this a whole number? No, it is not, because if it was a whole, how many parts would I have shaded? I would have shaded 5 parts, and my denominator would be 5. So my numerator and my denominator would be the same. Let's have a look at the next one. 9/9. So I've got 9 parts because that is my denominator. And then I'm going to shade 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can say that I have shaded the whole, so that one is correct because my numerator and my denominator are the same, which makes the whole. Okay, this one now. So if you'd have drawn this, some of you might have made the mistake of drawing one bar with 10 parts. However, if we look at our denominator is 3, which shows us the number of parts. So I need them in parts of, that's 1 lot of 3, 2 lots of 3, 3 lots of 3, and 4 lots of 3. Because I need to now shade 10. And obviously, if I shaded 3 in there, can I shade 10? Well, no, that's why I've got to draw another lot of 3. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it says which fraction is equal to 1 whole. Now if we look, if just one of these was coloured in fully, then I would have a whole. However, that's a whole, that's a whole, that's a whole. So actually I have 3 wholes. And then I have 1/3 left over because I've got 1 whole, 2 whole, 3 whole, and then I've got 1/3, so 1 part of 3 shaded. So we would say that this one isn't equal to 1 whole, it's actually equal to 3 wholes and 1/3. And the last one, I've got 7 parts, so I've drawn my 7 parts. I'm going to shade my 6 because that's what it says. Is it equal to a whole? No, it isn't, because my numerator and my denominator are not the same, and for it to be a whole they would have to be the same. Okay, and finally number 4, we need to divide 48 by 2. So I've wrote it out, 48 divided by 2. Now there are a few different ways to do this. You could have counted up in your 2's all the way up to 48, and that would have got you the answer. Alternatively, we could have actually partitioned the number into 2 smaller numbers first of all. So I could have done it, these are my 10s, these are my 1s. Well, I know I've got 8 1s and I know I've got 40 in my 10s column, so I could have partitioned it. Then what I could have done, I could have divided each of these numbers. So I could have done 40 divided by 2 and 8 divided by 2. Now, because 40's got a 0 on the end, we can take off the 0 and say how many 2's go into 4. Let's count it. 2, 4, so that's 2. And then put my 0 on the end. Then I can work out how many 2's go into 8. So 2, 4, 6, 8. So my answer is 4. And then if I add these two numbers together, I would get 24 would be 48 divided by 2. So that is another way that you could have done it. Alternatively, you could have done different numbers that you've partitioned it into, but that is another way. If you couldn't count all the way, because obviously you don't have 24 fingers, you could have either counted up in 2's and counted how many lots you had, or you could have partitioned it. So what is the difference between these two shapes? I want you to pause the video. I want you to say, what's the difference? What do you notice about these two shapes? You should have noticed that one of the shapes is 2D and one of the shapes is 3D. Now, the word D just means dimensional. So if it's 2-dimensional, it means it's flat. And if it's 3-dimensional, it means it's popping up, it's coming out, rather than it being a flat object. Now, what you might also notice about this is that your 2D shape of a square is actually on a 3D shape as well. So we're going to have a look at some different 3D shapes. First thing I want you to think about before we do look at some 3D shapes, how could you describe this shape? What could you describe it as? How could you describe it? What do you think? Now, I'm not going to run through ideas of how to describe it because we're going to talk about that in just a little while. But what I would like you to do is I would like you to have a look at some 3D shapes that I've put on here. Some of them you might have come across before, some of them you might not have done. So I'd like you now to have a go. You might want to number them up or just to point to them and say, oh, well, I know that's this shape and I know that's this shape. And I'd like you to see if you can work out what the name of the shapes are. Once you think you've had a go at all of them, or as many as you can, then if you play the video, we'll go through and I will show you the name of the different shapes. So looking at the shapes that you've just had a go at doing, I think a lot of you might have got a cuboid, because that looks like a rectangle, but it's a bigger version, so it's a 3D version of a rectangle. We've got a cube, which again is using a square, so lots of different squares to make up a cube. A sphere, you might have got a sphere, so like a football, you can kick a football, that's a sphere. A cylinder, so things like a pen, so my pen is a cylinder, it's a 3D shape. I've got a cone, like an ice cream. If you like to have ice cream in the summer, you can have an ice cream cone, so that's a 3D shape as well. And then we've got two which you might not have come across before. One is called a square-based pyramid and one is called a triangular prism. Now I'm going to talk about these in a little bit more depth so that you understand what these are. But just before we move on, I'd like you to have a little look around the room or look around wherever you are, and I want you to see, can you see any cuboids, any cones, any cubes, cylinders, spheres? And then once you've had a go at looking to see have you got some of those around you and find some examples, then you can come back and press play and look at the next part. So a square-based pyramid is a shape that looks like this. Now, a way that we can remember that this is called a square-based pyramid is, first of all, it looks like the Egyptian pyramid. So the pyramids that are in Egypt, it has got that similar shape. So it's where they go to one point at the top. So you can see that at the top of the pyramid, there is one point. So we know it's called a pyramid. And the reason it's called a square-based pyramid is because on the bottom, you can see that there is a square. Now, it isn't always a square, so on the next slide, I'd like you to think about some examples of what types of pyramids these are and see if you can figure out what they're called. So have a think of these. What do you think these could be called? Obviously, there are all types of pyramids, but what do you think? So now you've had a chance to have a think about what they could mean. Let's have a look. So they're obviously all pyramids because they've all got one point at the top that they all go to. Now we can have a look. If we look at the base of it, the first one, we can say it's either a triangular base pyramid or just a triangular pyramid because it's a triangle. Second one is a square base pyramid because it's got a square on the bottom. The next one is a rectangular pyramid or rectangular base pyramid because it's a rectangle. The next one, because it's a five-sided shape, it's a pentagonal pyramid or a pentagonal based pyramid. The next one is hexagonal because there's 6 sides on the base of it. And the last one is an octagonal because there is an there is the shape of an octagon on the bottom, an 8-sided shape. So each of these we can describe the shape of them because we know what shape is on the bottom and the fact that all of these sides go to a top to one point. Now we're going to have a look at what we call a triangular prism. Now a triangular prism looks something like this, and a way that we can remember that this is a prism and not a pyramid is by the following clues, because they can look a little bit similar, but one of the main differences is that this is a triangular prism because the triangle is on the outside. Now what you will notice that it is not a pyramid because the sides don't meet at one point. There's actually it goes to a few different points, so it's not one singular point that's at the top. So that's why we know it's not a pyramid and that it's a prism. Now you can see all around the centre, all around the middle, that there are rectangles. Now these are always going to be there on a triangular prism. So this is something else that we can look out for as a clue to spot which shapes are prisms. So now we've had a look at the first one. So for the example on here, the first one will be a triangular prism. What do you think the rest of these will be called? Because remember, the prism is a prism because it's got rectangles around the centre, but that it changes its name based on the shapes at the side. So have a think what these could be. So the first one was a triangular prism. What do you think the others are? Have a write down of them if you'd like. So let's have a look. So we've got a triangular prism, we've got a square prism, rectangular prism, pentagonal prism because it's got 5 sides on the outside of the prism, a hexagonal prism which has got 6 sides as the end shapes, and an octagonal prism because the end shapes have got 8 sides. So whilst you're sat around the room, maybe you can have a look and see what else you have got around the room. Can you see any of these? It might be a cardboard box, it might be all different types. So these are just some examples of some prisms. So we're now going to think about how we can describe a shape, so especially a 3D shape. So we've got different things called faces, edges and vertices. Now an edge is an edge where 2 faces meet, and a face is the flat side, okay? So I've just got a box here to help me. So if you've got a little cube box anywhere, you might want to have a look at doing this too. So you might want to pause the video and get a box as well. So I've got a cube here. Now, all my faces are the 2D shapes you can see. So actually, mine is more of a cuboid. So I'm going to have a look at my cuboid, which is similar to a square, but obviously it's just got some rectangles and some squares. So the faces are all the flat side, all the 2D shapes. So if I was to count around my square, around my cuboid or around my cube, whatever object you've got, you can count all the flat faces. So we've got 1, 2, 3, 4, 5, 6. So there are 6 faces on a cube or a cuboid. Now, an edge is where 2 faces meet. So an edge is the corner. So if you feel it's quite rough, so that's what your edge is. Okay, so if we actually count them on here, I've got 1, 2, 3, 4, but then I've also got them on the top and the bottom. 5, 6, 7, 8, 9, 10, 11, 12. So your edge is the edge where 2 sides meet. So if these are my sides, my edge would be down the middle. My 2 faces meet. Now we've got something called a vertices. Now a vertice is just a big word for a corner or a point. So anywhere where there is a corner or it feels sharp like a point, that is a vertice. So if we count 1, 2, 3, 4, 5, 6, 7, 8. So I have got 8 vertices. So obviously we can see that we can describe shapes in different ways. So I'd now like you to have a go at doing this one. So obviously we've got the shape of a triangular prism. And I'd like you to have a go to see if you can work out how many vertices there are, how many edges and how many faces. Once you've had a go, you can write this down and then come back and we'll see if we've got the same answers. Now I'd like you to have a look at this one. So obviously we have got, what shape is it? It's a triangular prism. Well done if you spotted that. So we can have a go at trying to figure it out. So I'm going to get a different colour and I'm going to mark on, and I'm going to do the faces first. So there will be 1, 2, 3, there'll be 1 on this side, 4, and there will be 1 on the base, 5. So there are my 5 faces. Now when I have a look at my edges, so they are all the silver prongs on my picture here. So if I get a different colour now, so they were the faces, I'm going to now get a different colour. I'll use a red. So for my edges, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, and then there'll be 1 at the bottom, 9. So there are 9 edges. And then for my vertices, which are my corners, remember my points, I can count 1, 2, 3, 4, 5, 6. So I've got 6 vertices. So now you can see a face is the flat part, the 2D shape, and edge is where 2 faces meet, so it'll be the middle part, the middle line, and then you've got your vertices, which are the same as a corner. So I'd now like you to have a go at doing this one. This one is a bit more of a challenge. Which ones are the edges, which ones are the vertices, which ones are the faces? So I'd like you to have a go at figuring out, writing it down. So obviously we've got a cylinder. How many vertices can we see, how many edges, and how many faces? Once you've done that, come back and we'll go through the answers. Okay, so let's have a look to see if we got the same answer. So I'm going to use my pen as my cylinder because it is a cylinder shape. So I can see, if I have a look at my faces to start with, so I have got 1 on the top, I have got 1 on the bottom, and then I actually have 1 that goes all the way around. So I have 3 faces. Now if I look at the edge, I've got 1 edge that runs around the top, I have 1 edge that runs around the bottom, so I have 2 edges in total. Now there are no vertices because I haven't got anywhere where there is a corner or a point, so I will not have any vertices. So now I'd like you to have a go at doing the worksheet. Then this is on Seesaw Activities for you to have a go at doing. So you've got different questions about different 3D shapes. So I'd like you to have a look at this first of all, and I'd like you to work your way through this. Now once you have had a go at doing this, I will then go through the answers so that you know whether you've got them correct or not. So let's have a look at the answers then. So for number 1, we want to make, it says Kim paints the faces of some 3D shapes. She stamps the faces on a sheet of paper. Match the stamp to the 3D shape. So we can see that the circle will be on the top of the cylinder, the square will be on top of the cube, and the triangle will be on top of, I think that one looks, it's quite hard to see that one, but I think that one could be a triangular based pyramid or a triangular based prism. Okay, for number 2, a cube is a special type of cuboid. What is special about each face of a cube? Well, we know each face of a cube is exactly the same width and exactly the same length because a cube has got all sides which are all the same length. So thinking about that, which shape is the cube? Well, it is going to be the yellow shape because it shows that every single side is the same length, whereas a cuboid would have different size lengths. So number 4 is here is a cuboid. What do you notice about the opposite faces of a cuboid? Well, they're going to be identical because a cuboid has got sides which are, some sides are going to be the same length and width and others are going to be also the same. So we can say that the opposite side of the cuboid will be identical to the ones that we can see here. And for number 5, match the 3D shapes of the label. So obviously the purple one is a cylinder, the second one is a cone, and the third one is a square-based pyramid. So number 6, here are some shapes. Circle the triangular prisms. So again, we're looking at the prisms on here. So using some examples of some realistic objects. So we can see that the ones that are circled are prisms. If you circle the middle one, it has got triangles around, but if you remember, this one is a pyramid, not a prism, because there's one point at the top. Circle all the spheres, so you should have circled all of them apart from the rugby ball, because the rugby ball isn't a circular, it's almost an oval shape. And then for number 7, complete the table, so the number of edges, the number of faces, and the number of vertices. So you could have drawn on the actual shapes to circle or to find all the lines, so you could see the number of each. So if you want to have a check of yours to see if you have got the same. For number 8, here is a cuboid. Shade a face that is 5 centimeters by 3 centimeters on the cuboid. So the shape, the side that you should, the face that you should have shaded is the one above. This is because it's 3 centimeters along the base on the horizontal lines, and we can see that the vertical lines will all be 5 centimeters tall. So this is why we know this would be. What are the measurements of one of the other faces? So we could have said it's 10 centimeters by 5 because it's 10 centimeters along the base, but the horizontal lines and the vertical lines are 5 centimeters tall. Juan sorts some shapes into prisms and non-prisms. Can you talk to your partner about what a prism is like? Now, a prism is, obviously we know that a prism has got rectangles around the centre, it has got or sometimes some squares, it has also got different shapes as well on the outside, whereas non-prisms, so these ones aren't prisms because they almost look like a cylinder to a prism, however they're different shapes around the outside and around on the edges as well. So the non-prisms that we can see are obviously not these.